Hello, everyone. My name is Alex Key, as I've been introduced, and we're going to talk about some of the high availability best practices with the Oracle database. If you are using .NET as your middle tier, or if you are a .NET developer, and many of the typical Oracle HA sessions are, usually cover just focused on the database, and it's for DBAs. This one, we're going to focus on developers. Much of the functionality I talk about today is generic actually to the Oracle database, but we'll talk about what you need to do in your .NET application to use it, which generally isn't not much, and we can talk about ways in which you can optimize your application so that it can be highly available for your end users. Most of the features I will talk about will be pretty simple to use in terms of what you need to do from a development standpoint. It may involve no or very little changes to your code and or configuration on the .NET side, because many times the failover is going to just be handled transparently as long as you have these specific Oracle features on, and you don't need any manual intervention when a failure occurs or when you have planned downtime occurring. The application and the end users will be able to handle it, and the end users won't see any sort of outage or whatnot or get any error. The application will be able to go to, say, the next rack node when there's an outage that occurs in, say, one rack node. It goes to a second rack node instead, and the user will be seamlessly transferred over and won't notice any outage occurring. And that's because the database server and the client are working hand in hand. And the end goal is really to mask as many failures as possible between the end user so that they have a great service level. So this is our agenda today. We're going to first talk about just the application HA concepts in general, and what we're trying to achieve and what the HA functionality Oracle database and .NET has, what it's trying to accomplish. And then we'll talk about the actual technology itself, starting with fast application notification. We call that FAN for short. And then we start entering in the different types of scenarios and how the specific FAN technologies or non-FAN technologies in some cases, there's some HA technologies that don't use FAN, will help you in a planned maintenance scenario, and also the more difficult unplanned outage scenario when all of a sudden you have a failure, a node goes out or a cluster goes out. What do you do? Or what does Oracle do that you can have set up in order to take care of that? And the focus in your .NET application will generally be the Oracle data provider for .NET. And OTP.NET is what, if you're not that familiar with .NET development with the Oracle database, is the data provider that you use to connect to Oracle and get data, return data back to the database, things like that. And it works hand in hand with FAN and other Oracle database technologies in order to enable this high availability. So let's start looking through some of these features, and starting with talking about general application high availability. So what happens if your application doesn't address high availability? What kind of scenarios might you be running into? These are some of the common things that you might see if you run any type of enterprise app or just a regular app sometimes, and you hit some of these types of error situations. If you have a TCP IP timeout, your end users could be waiting a long time for that timeout to occur, and then they get an error at the end of the timeout. So that's kind of a service level hit to your application that you don't generally want to take. Sometimes connection requests hang when the services are down. If a database node or the entire database is brought down for maintenance, or if there's a failure in the network, failure in a hard disk, or some kind of the node itself, then your machine is not accessible, your database server is not accessible to the user, and then they experience a poor service. They don't, maybe if you bring another database up to offload some of the load that's occurring in your cluster, you don't have connections going to it. Another issue might be receiving errors during planned maintenance. Obviously, at some points that machines need to come down, and so if that happens, how do you make sure users aren't going to use the machine that's going to be brought down in a minute or two? So these are all kind of issues that come up, and what we're trying to do here in this session is help you resolve all these types of issues, which are very hard to solve from an application developer standpoint. To be able to design your application from the database to client to handle all these situations is hard. But what we've done in Oracle is put this as a fundamental part of the Oracle database and have that work with most of the time with the Oracle Data Provider.net connection pool. And you'll be able to handle these generally transparency or through a few small changes in your configuration or your connection pool API. So again, these are very hard to resolve with by yourselves as individual application developers or even as DBAs, but can be done with some technologies that Oracle has in its database and OTP.net. So our goal ultimately is to make these Oracle.net applications highly available, not just Oracle database servers. We have a lot of great HA technologies in the database, but the end goal really is that you want your end users to have high availability, not your database just to have high availability. It has to be the mid-tier to the database working together for that to happen. And then they have to provide the high availability in a transparent manner so that the end user doesn't have to deal with it, as well as ideally your DBA doesn't have to deal with it either. When the failure occurs, it can just happen and fail over to a new system transparently without having to do any manual intervention at 1 a.m. in the morning or at times when it's unexpected and the staff has to scramble. And at the same time, you as developers also would prefer that these type of failures be handled gracefully and automatically without having to do any specific development. That way you can get to market sooner and you don't have to deal with a lot of the same failure cases over and over again as you go from application to application and add code, test it, things like that. You can just implement what Oracle has already provided and tested and use that. So at the end of the day, what you are going to see are better service levels for your end users, less administrative overhead for any times you get a failure, and it's going to lead to a faster development cycles because you don't have to do this development over and over again for HA. So the key technologies you do need to use for these HA solutions on the database server levels are things like RAC, DataGuard, Golden Gate, Global Data Services, RAC OneNode. If RAC is real application clusters, if you're not familiar, that provides a clustering solution for an active type of database. DataGuard is our disaster recovery solution at Oracle, and it provides the ability to have kind of a backup database server that can turn active as soon as it finds the primary has gone down. Golden Gate provides replication. Global Data Services I'll describe in a little bit, but all these are kind of HA high availability database solutions, and OTP.net works hand in hand with each one. And we're going to talk about the technology within these, which actually share a commonality, such as FAN, and being able to use FAN across them is what makes a lot of these HA technologies that I'm talking about possible. So we're going to focus on two main scenarios: planned maintenance and unplanned outages, and then talk through each what are the best practices for each one, and how errors and interruptions are automatically masked during these outages, so that if there is a server up and ready to take over in case the primary goes down, or in case the node in which the users are connecting to goes down, that outage is transparent to the user. They don't see it. They'll see a pause, and then they can continue their work when they get reconnected, which will happen automatically in most cases. So let's talk about fast application notification. That's the secret sauce for a lot of these HA technologies, and and it works, whether you're using Rack, Data Guard, whatnot, all these technologies I was talking about, global data services. And FAN specifically works with OTP.NET connection pools. So if you're going to use FAN on the server side, you have to use OTP.NET pooling on the client side. And I'll talk a little bit about, if you're not using pooling, you can still use another technology called Transparent Application Failover. But most people are going to be using pooling so they can take advantage of fast application notification. So what is FAN? FAN is really just a server-side messaging platform. So what we have is a cluster-ready services, CRS software running on the Oracle database server. And what it does is it monitors all your database nodes, your services, and whatnot. And when it detects a change in them, that change could be a down event in which a node goes down. It could be an up event. If a node goes up, it could be load percentages on that specific machine. When that happens, that CRS will send a message to OTP.NET pools and telling each of them, hey, what is the status of the database server machines? And based on those messages, OTP.NET can adjust accordingly. And that adjustment might be, oh, I saw this node goes down. I will no longer, I will release all connections to this specific node that went down, and I will make sure new connections are not created to this node that went down. So it can adjust its connection pool behavior and its connection allocation based on what the server is telling it about the status that all the machines and the services it has on the server. And so, so that's something that we do. And if you are already using FAN, you'll note that in OTP.NET 12c and higher, we've changed the infrastructure underlying FAN from using Oracle AQ to the Oracle Notification Service, ONS. And that's just the implementation of how FAN works, is that moving to ONS allows us to have a more scalable infrastructure for FAN. It's faster. It also eliminates a firewall issue that used to occur with the older implementation with AQ, supports activated guard, and other services are using FAN with ONS. So we've all consolidated with ONS. And if you're using OTP.NET 12c, you're pretty much always going to be using ONS. If you happen to be using unmanaged OTP.NET 12c against an Oracle Database 11.2 or earlier, you'll still be using AQ. If you're using OTP.NET 11g, you'll still be using AQ, but eventually, as everyone upgrades, they'll always be using ONS, and that's optimal, really. And I mean, a big reason why we wanted to move to ONS also is that it's fast. The messages that people are getting are out of band messages. They're not waiting for say TCP/IP timeout to clear before sending the message that, hey, the network's the database is down, and wait for the TCP/IP timeout to happen, which sort of already tells you that the database is down. But what we try to do is to say, hey, as soon as we detect the failure, we want to inform you. So we use ONS and an out-of-band message in order to get that to you, to the connection pool faster, so that it can react to that new event. So what are the events that FAN does report to the OTP.NET connection pool? Well, these are those events, and the granularity level, before I get into it, is that it will report these events about each service member, about each database, or each instance, so that we have varying levels of granularity, so that we know if, say, the entire database went down, such as in a disaster recovery solution, OTP.NET knows that, hey, the entire pool needs to be cleared if all the connections are going to that database, and we need to do a failover to the standby instance in the data guard situation, for example. So it knows that type of granularity. If it's only, say, one rack node, for example, OTP.NET will say, okay, I've been informed rack node B has gone down, I need to just clear out only connections for rack node B, but keep the connections for all the other rack nodes available, and so that end users can continue using it. And then when I allocate new connections, I will just allocate new connections to any other rack node that's still up and not to rack node B anymore. So that's the type of intelligence we can do based on this. So what are the event types? So we've got the down event, which should be obvious. It's when you get a failure of one of these service members, database, etc. So that's something that OTP Night can react to. We also have a planned down event, and a planned down event is different from a down event, which is a down event is unexpected. A planned down event is when the administrator of the database says, I'm going to do a planned shutdown, and I need to drain, and what it tells OTP Night to do is drain the sessions for that planned maintenance. And usually when the planned down event occurs, there's a period of time before the actual machine goes down. So it allows those sessions to be drained until the machine finally goes down. And when the machine does go down, the down event gets set. There's the up event, in which can be important. Not so much for an HA level, although it is helpful for being able to perform well and have a better service level, not just from a speed perspective. It can be useful in cases where, for example, you have a rack cluster, you're finding your rack cluster being heavily loaded because a lot of people are using it for, it's end of the month, maybe end of the month processing. So what you might want to do is bring another couple rack nodes to the cluster, and when that happens, an up message gets sent to OTP Night to say, hey, there's 2 additional rack nodes available that your application can use. And what OTP Night will do is start allocating more users as they connect to the application to those rack nodes, rather than to the ones already being heavily loaded down by existing use. So that way you get a balancing of the across all the cluster much quicker than if it was just some random round robin type of algorithm. It's actually based on, round robin algorithm. And we've kind of enhanced that even further by sending to OTP Night load percentages. So how much each rack node or each cluster or each rack node is, how heavily is it loaded? We take the CPU percentage, and if it's 80% loaded on CPU, we know that, hey, this machine is pretty heavily loaded. So when someone tries to connect upon the next open call, I'll try to connect them to a machine that's much less loaded than this one that's 80% loaded. And then we have the ability to do affinity, which becomes important in a distributed transaction scenario. When you have a distributed transaction, you want all your branches to co-locate on the same node. That way they all fail or succeed together, because if you locate them on 2 different nodes, what may happen is if one node fails, now you've got a split brain problem. So the affinity marker allows OTP Night to know that if an existing distributed transaction is being used and additional branches are being added, to locate that work onto the database node that's already started that distributed transaction. And one note I want to talk about the up and the load percentage is that that feature is called runtime load balancing, or RLB. That's not so much an HA feature, so I'm not going to talk that much about it in this session, but it's more of a performance and maintaining a high service quality feature, performance level feature. But it's another useful part of FAN, but not specifically geared to HA, so I'm not going to talk that much about it. I do want to mention specifically about global data services. That's a new server feature in 12c. And what global data services does from an HA level is it extends FAN to be on a global basis. Whereas before, each FAN could provide your high availability only within one cluster or one machine, or across maybe some data guard instances. What global data services does also is allow you to extend FAN to all your database, all your Oracle database system globally, so that it can act as kind of a super cluster across geographies. And it works with all of our, most of our HA technologies. So RAC, Active Data Guard, Golden Gate, they can participate in global data services. And really, it optimizes HA, but you can also see that utilization can be optimized. For example, if you have your US-based servers heavily loaded and it's nighttime in Japan, you can offload some of the work to, say, Japan, assuming that you still get a good performance level with the if you're a US-based customer across the ocean, but a fan will take account into that. But that's the type of thing that you could start using resources in other global data centers, even though they might be in another cluster. And the great thing about GDS is that you don't have to make any code changes. Once you have fan working with your rack cluster or with your data guard instance, you can just enable it. It'll be enabled automatically once you start using global data services. It will just immediately pick up, hey, the messages that CRS is telling us apply to this GDS kind of cluster as opposed to just a localized rack cluster. So that's automatic. You don't have to make any code changes for that. And I'll talk about what code changes that you do need to make for enabling fast connection failover and fan in just a minute. The other requirement is that you use Oracle Database 12c and OTP.NET 12c, obviously, because it's a new 12c feature. So without GDS, just to visually illustrate what's occurring is you could have, here you see that you have two clusters, one on the left and one on the right, both sales services, and one could be servicing European customers, another one could be serving American customers, and that's all fine and good. They're replicated across, but the thing is, you'll notice about the two clouds is the sales service folks logging in. They are using connection pool localized to each data center because that's the only ones they have access to. But that was before GDS. After GDS, that sales global services you can see is one large cluster here. I'm sorry, one large pool, I should say, right here. And what that pool does is that, if your data center on the left here goes down and these two servers go down, these users here would normally be in trouble. They wouldn't be able to access their application anymore. But because this system is still up and you're using global data services, those users can access the connection pool still, and thus can use these servers. The service level may be a little slower because now that system is being more heavily loaded, and if it's in another continent, obviously you have the latency of waiting for the packets to go back and forth across the oceans, but at least they have service, and that's what this global data services does and what OTP.NET can support for it. So let's dive into how this technology works more and how you enable it on the OTP.NET side. And we're going to talk about it by going through scenarios in which most customers have, in which they want to maintain high availability. And the two primary scenarios are planned maintenance and unplanned maintenance. So we'll talk about planned maintenance first. It's the easiest because with planned maintenance, you know exactly when your failure, well, I shouldn't call it failure, you know exactly when your downtime is going to occur. So again, you have to use the OTP.NET connection pool if you're using fan. So your administrator will bring down a server. Maybe they're doing some maintenance on the hardware or doing an OS update, but for whatever reason, at some points in time, there's going to need to be some downtime. So what you want is you want your end users to be able to keep working through that downtime, perhaps connect to another one of the nodes in your rack cluster, for example, would be something you would want to do. So what happens when fan alerts OTP.NET that there's a downtime that's going to occur in that scenario? What OTP.NET will do is first, it gets the fan message and it will stop allocating any new connections to that database node if it's being told that the node is being taken down. Next thing it'll do is it'll close all the idle connections, so anything in the pool connected to that node will then be closed and disposed. Lastly, it will, anytime someone brings back to the pool any connection to that node, that connection will then be closed and disposed. So when the message occurs, the first two things happen, which is stopping allocation of new connections and also closing idle connections so that no one gets any connections to that node going down. But users can continue their work because the downtime hasn't happened yet, and there's no reason to take down the connection. But as soon as the connection is returned, you remove that connection from ever being allocated again so that no one else can continue using that node, so that eventually all the connections are drained from that node so that the node can then be brought down safely without interrupting anyone's work. And this is our pool draining feature that's part of our fast connection failover. Fast connection failover works in both planned and unplanned outages, but here we're talking about planned outages. And pool draining is a key part of ensuring a high service level as during planned maintenance operations. You can set a timeout for how long you want you want to wait before the downtime occurs. So you don't, sometimes users may be holding on to a connection indefinitely, and at some point you do want to take it down, so you can set a timeout for how long you want to wait before forcing a customer off, which is not ideal, but the better thing is that it's up to you or your administrator to decide, I'm willing to take the service level hit for those users if it's taking too long, because it's worth more for me to get started on doing some kind of maintenance on the machine rather than waiting. So in the end, it still means less or little to no end user disruption. So how do you set this at the OTP Night level? Well, we have the pool draining. We start by saying pooling equals true, and then setting HA events equals to true in the connection pool attribute. And if you're using OTP Night 12.2, these are on by default. And because they're set to true by default, you don't have to do anything. You're done. So by default, these are on. All OTP Night is waiting for, well, I should say, as an application developer, you're done. You don't have anything else to do. For an administrator, they certainly have to turn on fast connection failover, issue the right commands, things like that. But as an application developer, you don't really have anything else. It will all be handled transparently. Not many coding changes here at all, if any. And we do recommend, if you are using this technology, to use 11.204 or higher. We've done a lot of new additions to it and new enhancements and bug fixes, of course, and we find that the customers get really good service levels with 11.204 stack end-to-end of both the database and OTP.NET. So that your administrator could issue the command you see in red at the bottom, server CTL relocate service, and then what it'll do is you'll see this drain timeout of 120. That means in 120 seconds, 2 minutes, shut down this specific instance. And what it'll do is it'll wait 120 seconds to allow end users to drain their connections away before explicitly shutting down the instance. So that's great in a in a scenario where you have rack, in which you have multiple rack nodes that are active. It's a little bit different in a data guard switchover, which is a common, data guards commonly used. So what you in a switchover, what happens is that when you take a database down and you're taking the entire database down, what happens is the database is shut down, and then the standby database is brought up, but at no point are both the primary and the standby running at the same time. The primary needs to be shut down first before the standby comes up. And what you would expect is there's going to be a period of time in between that in which there's no database to service the end users. So what we want to do is to be able to have not deliver errors at that time, but just have the user wait until the standby comes up. There's users waiting. It's kind of no use to tell them you've got a timeout issue. There's going to be a timeout issue because the database will take a little bit of time to come up and set itself up to be able to take connections. And of course, as soon as it comes up, there might be a storm of connections coming in too. So that's going to take time. So during a switchover, we have this option to set up a wait. And that wait option, will tell OTP.net how long to have the user wait before you start delivering error messages that timeouts could occur. So so this parameter is key when you're doing a switchover in terms of setting the pool's expectation for how long it should pause the connections that are trying to come in and access the standby database, how long to pause them before delivering an error message that the connection request is timeout. So this is something that can improve your end user experience, because it's better to have them wait for the standby to come up than to immediately deliver an error message. Obviously, if it's not an overly long time, so it prevents this generation of numerous error messages as a user tries to connect, gets a failure, connects again, gets a failure, connects again, gets a failure. It's kind of like a not very useful type of iteration. So instead, what we do is we tell them, hey, pause this request. We're not going to deliver error message, but we're going to wait, because it's no use to have them error out, come back, error out, come back. We should wait until we can likely have a time that the standby comes up. If it doesn't come up in that time, you probably do have an error in which the standby database isn't coming up for whatever reason. So on the OTP.net side, we've introduced, to enhance this, we've introduced this service relocation connection timeout option setting in our .NET config. And what it does is that it blocks these incoming connections until the standby is up. Now the wait parameter you saw here will set that service relocation connect and timeout. It can take a wait time from that if you want. It can take it from there, or as an application developer, you can set it for longer if you like. So you can change that if you want on the application level, or you can just take the default of 90 seconds or whatever the administrator has set for the wait time, or you can set it yourself. So it's up to you, as we give you that flexibility. But essentially, it does the same thing which I described, which is it just pauses the connections and waits. It's just something you can set on the OTP.net side as an application developer. And that's something in your .NET config. A couple more pieces I wanted to introduce to you is the retry count and retry delay settings. These are also can be used hand in hand, and they can enhance your service relocation connection timeout or your wait time. So after the SRCT or wait time expires, you can use these retry count and retry delay settings in your TNS names in order to start trying to access the standby database. So retry count will iterate through the address list to try each service and see if it can access it. And to prevent, the storm from happening in which everyone's trying all at the same time and then it's retrying repeatedly, there's a retry delay to give it a time to pause before it retries again. Because obviously, if you tried all the addresses once or twice or whatever, and it hasn't worked, you probably need to wait a little bit of time. So that's why you have the retry delay there. And to set these, you just put it in your tnsnames.aura, and you can see here the retry count setting is 10. So try is 10 times, and in between after iterating through all the address lists, wait 5 seconds. So that's what it's doing. And another thing I recommend is always use a service that is not the default database service. Most likely during a switchover situation, the default database service is going to be the one that's going to be hit on the most. And you might want to try some of the other database services in order to try to connect to those first, so that you're not trying to all allocate to the same systems at the same default system at the same time. So if you happen not to be using a connection pool, what do you do? We still have a solution for you. It's called Transparent Application Failover, or TAF. And TAF works at the Oracle call interface level. So it's at the client level that this is working, and it's not server initiated type of functionality. And what happens in a planned outage scenario is that TAF doesn't it doesn't use the fan infrastructure, but it will still detect these failures, or I should say it will detect when it's lost connection. So it'll automatically, first thing it does is it'll automatically connect to an available database instance if there's another node or your data guard instance is available. It'll restore, in 12.2, it'll restore the session state now. So your NLS settings, your time zone settings, your action, your module settings will be restored, which is a great new feature. You don't have to have application logic to restore those. TAF will automatically redo it. We'll restore those now. And then it'll also, in a read application, it will reposition your cursor to where it was prior to the outage, so that you don't have to do that yourself, where you requery and then try to figure out where the user was at that point in time. Fan can do that. I'm sorry, TAF can do that for you. And it also will replay your initial transaction statement, which is something new in 12.2. So NADML or stored procedure. Now TAF, because it works at the Oracle call interface level, is only available with unmanaged OTP.NET. Fan is available with both managed and unmanaged, so you can use Fan with either of those, but if you're using TAF, you have to use unmanaged OTP.NET. So that was planned outages. Let me talk about the unplanned outage scenarios. So in an unplanned outage scenario, we use fast connection failover again. And fast connection failover works just like it works in the planned outage scenarios, with one exception. And let me just go over how it works the same. It stops allocating new connections to a failed entity, and then it closes the idle connections. And here's the difference between the planned and unplanned outage scenario with FCF, is that active connections are closed. So whereas in the planned outage scenario, those active connections remain open until the work is done and the connections is returned to the pool. In this case, because the node or the service is lost immediately, those active connections are closed immediately as well. So the benefit of this is that just like in the planned outage scenarios, the user does not use any invalid connections, and there's no need to clear the pools manually. And one added benefit also is that no application developer work needs to be done except for some minor changes, and those minor changes again are the same as what you had before, which is the setting the connection pooling to true because it uses fan, and also setting HA events to true. That's the only two settings that need to be made, and of course those are already both true if you're using 12.2. In this scenario, you can also use TAF and pooled and unpooled connections. So unplanned outages work just as great in unplanned outage scenarios as they do in planned outage scenarios with TAF. So same things happen that I just described, and just wanted to note that the 12.2 version of TAF, the new features really make things easier and really extend the ability to use TAF beyond read-only apps. It now supports has some basic transactional support, so that you can start supporting write apps or things that start changing data. So that was fast connection failover and TAF. Let's get into some more difficult to handle scenarios and how Oracle tries to solve these. And some of the more difficult scenarios is trying to be solved by this feature called application continuity. And what we're trying to solve is when you have an outage and a recoverable error, what happens if you have some active queries or transactions going on? When you lose that connection to the database and then you have to reestablish that connection, say you have a network error and you lose that connection, or some kind of a database error occurs, disk error, things like that, where you no longer have access to the disk. How do you know if your transaction went through or it didn't go through? Because when you reconnect, you want to be able to tell the end user, hey, what you were doing committed or didn't commit, or you should roll back. And how do you also handle that automatically so that the end user doesn't have to, even if you can tell the end user, you want to be able to say, okay, you were in the middle of the work, but now you lost all that work, so you the end user have to manually redo it and also figure out if it had committed or not. So that's the type of thing that as an application developer, you're like, well, that's a really, really hard. But what we've done with application continuity is solve some of those scenarios in which when you get a recoverable error and you lose access to those in-flight work, we can reestablish a connection and restore that in-flight work, because with application continuity, Oracle's recording what is happening with the end user, and then be able to restore that state when they reconnect to the database, and be able to tell them with certainty whether their transaction committed or did not commit. And then be able to roll back that transaction if it's in an undefined state. So the benefit of AC is that what you have is the ability to mask many hardware, software, network storage errors, timeouts from end users, so that they don't see an error. When an error occurs, it will be handled automatically. So that's easier for administrators. It's easier for you as a developer. There's no additional coding required. And to the end user, what they'll see is just a delay. The failure occurs. OTP.NET sees that a failure occurs, reestablishes a session in a database that's active, that has access to what was recorded for the in-flight work, replays that in-flight work, and then restores control back to the application user. So it's something that we have available with Rack OneNote, and Active Data Guard. So one of the things I do want to say is that the reason we can give a certainty with a transaction is we have a durable commit message. It allows us to know for sure what happened with the transaction, and it will prevent you from committing the same transaction twice. At least we can tell you whether it's committed or not, so that you know, okay, for certain, I don't need to try to execute it again. So how do you use this if you're an application developer? First thing you want to do is set your pooling to true, which is on by default, and your application continuity in your attribute in your connection string to true, which is also on true by default. So this AC connection string attribute is something new in OTP.NET 12.2, and they're both on. And if you're not using AC, that's okay. You won't get an error. We just all application continuity equals true means is that OTP.NET will try to get messages and be open to those messages. If they don't come, that's okay. There's no error if you turn it on but not use AC. That's why we have it on by default. But if and when you turn it on, you can start immediately using it. And because it's a 12.2 feature, you do need OTP.NET 12.2 and Database 12.2 to use it. So let me describe a little bit about what is going on in the background, because AC is a big feature and we're handling a lot of the work transparently. And you might be saying, what is being handled transparently, so that you know as an application developer what you need to do, what you don't need to do. So under normal operations, you're going along. What does the pool do? Well, if a pool is using application continuity, it will know that in the connection pool that AC equals to true. So what happens is that when there's a database request, the pool marks database request boundaries, and a database request boundaries is just a unit of work. And for each unit of work, the Oracle client library, in this case OTP.NET, will hold all the calls, or capture the calls, the inputs, and the results of those calls. And then the server will then decide which calls can be replayed theoretically. And when each unit of work finishes, the client purges the queue so that it doesn't need to worry about that anymore. So when the unit of work is done, like in a transaction, then the transaction's done, it's committed, then you don't need to replay it anymore because the transaction's committed. So what happens if you have an outage? First thing that happens is the reconnect phase, and the second major thing that happens is the replay phase. We replay the in-flight work that occurred already. So in the reconnect phase, what OTP.NET tries to do is check if replay is enabled. If AC is enabled, replay is enabled, then obviously, hey, let's try to reconnect. If it's not, then it isn't, and then you stop right there. But it will check first, and then it will verify that it's timely enough to reconnect, so that if For example, if you waited, a day before you had your standby database come up, then obviously it's not going to be timely, and there's no use to replay it because it's been far too long gone, and it's something that you probably don't want to reconnect and try to replay, because the database, if you wait too long, the state of the database may have changed, the values and other things in the database may have changed enough that it would not make sense to try to replay that transaction. It may cause some other problems. So you want to make sure that the period of time, and what OTP Night does is checks to make sure that period of time is short enough that it makes sense to replay that transaction. And then it will create a new connection, and then check if the target database is valid. It will want to know if the same schema is there and the same kind of server is there, if it's a valid database target, because obviously you don't want to be connecting to a service that doesn't have the same exact profile as the one that was originally had the problem. And then you use transaction guard, abbreviated here as TG. You use transaction guard to force the last outcome. So if it'll check if that last transaction committed. If it hasn't committed, it can roll it back. But I'll talk a little bit more about transaction guard later, since that's a key technology you can use on its own. And then what happens after that is the replay. Once you connect it, you replay it. And in the replay, the client replays all captured calls and ensures that the results returned to the application match. So you want to ensure that that what you're getting back from replaying the transaction is what you got back originally. And then if that ensures that that everything's in sync between the client and the server. And then if everything is successful, AC is done. It returns control back to the application and to the user. So that's in a nutshell how AC works during a failure and reconnect and replay. Now, this is a very, very hard problem to solve, which is why we solve a significant number of scenarios, but we're not solving every single possible scenario with application continuity. There are some restrictions. Some of those restrictions include that after the first commit, replay becomes disabled, so you no longer are be able to replay after the first successful local transaction. Some of the alter session operations aren't supported. Active Data Guard with read-write database links aren't supported. We don't support distributed transactions yet, and auto commit calls are not supported. But we are enhancing application continuity as time goes on with each release with more and more features. It's kind of just, we're starting with the basics and most common features and start extending some of the less common features that people use. And in our next database release, XML data types will be supported for application continuity. Okay, transaction guard. So transaction guard is you saw in application continuity, is one little part. It handles the transactional part of maintaining the message of whether a commit happened or a commit didn't happen, or what state exactly the transaction is. And what its key focus is maintaining a durable message for determining whether the state of the transaction, the local transaction you were in process of using when a failure occurred. And so AC automatically uses transaction guard, but you can use transaction guard on your own through some OTP.NET APIs in order to handle more scenarios of failure that maybe AC doesn't cover just yet, but you can handle your own programmatically to cover more of these scenarios. If there are things that you would like AC to support but aren't there yet, you can develop your own type of applications to handle that. Because the most important part of any application isn't necessarily in a HA standpoint, isn't necessarily restoring the session state and getting the user to be back to where they were operating when the failure occurred. It's making sure that transactions only commit once and getting certainty of whether a specific transaction occurred or not. And one of the worst things that happen might be having your transaction commit twice, or expecting the transaction to have committed, but when it really didn't. So this benefit of transaction guard is just knowing for certain what is the transaction outcome. The Oracle database will store that, and OTP.NET has APIs to allow you to retrieve that and be able to act upon that transaction. So the two APIs we have are, or set of, it's more than two, but the two general areas you'll be using are a set of Oracle connection properties that return transaction status, and an Oracle logical transaction class, which provides you a handle to the transaction object. And this requires just 12CR1 or OTP.NET and 12 OTP.NET 12CR1. And just to go through the scenario that occurs in a transaction guard situation is OTP.NET will first receive a fan error that a down event has occurred or an error has occurred. And when that error occurs, the end user may be in the middle of a local transaction and will have to be able to know for certain whether that transaction committed or not. So first thing that an application developer would do, since this is kind of an API-based feature, is first determine whether the transaction is recoverable or is not recoverable. So it'll try to check this transaction status. If it's not recoverable, it'll roll back the state of the transaction, and then but if it is recoverable, it'll resubmit that transaction so that it can attempt to commit that. So if it's the resubmit scenario, what you want to do then is start using the Oracle logical transaction, and you access it through the Oracle connection object, and then from that Oracle logical transaction, you try to get the outcome, exactly what state that transaction is, so that you know how to resubmit it from there. Now, it's possible that that transaction is, when it's recoverable, may already commit in that time that you're trying to find out the outcome of it. So when you ask for the outcome, if it's committed, then you're done. You don't need to do anything else. You've guaranteed that the transaction has committed. But if it hasn't committed nor has it completed, you have the option to then resubmit it if you want. So this is done by the application developer, and here's an example of what type of application logic you would add in your C# code. So here we're in the exception block. We capture the Oracle exception, and then we want to see if it's safe to resubmit by checking if the error is recoverable and the transaction has not been committed. So in red are the key APIs that we're using. First, we want to check the exception. Is it recoverable or not? We also want to make sure if it's recoverable, is there an Oracle logical transaction object associated with it? Because it could be recoverable, but maybe there is no transaction occurring at that time, so it doesn't matter. So there would be no Oracle logical transaction object. As well as we want to check if it's not committed. So here we're checking committed is not committed. So if it's not committed, there is a transaction in process and it is recoverable. Well, it's safe to resubmit work. Else, do not resubmit work. Since there may not be a transaction, it may not be recoverable, or it may have already committed, so you don't need to worry about it. So that, in essence, is transaction guard. And I know I covered a lot of technologies, and you probably have questions about which ones work with which. Since there's different database server technologies and different options such as RAC, Data Guard, Active Data Guard, and this matrix here kind of gives you an idea of what works with what. So with FAN, it works with RAC, it works with Data Guard when you have clusterware, it works with Active Data Guard with clusterware, it works with RAC and Data Guard together, works with Global Data Services, but doesn't work with Golden Gate. RLB, which I didn't talk about that much, you can see the columns here. TAF works with everything except for DML retry in Golden Gate. Transaction Guard works with everything except Golden Gate. Application Continuity works with everything except for Golden Gate, and Data Guard Physical Standby. So this is kind of, in a nutshell, what works with what, so that it's easier, so that you know based on the server technology you use, and also which fan technology or which HA technology you use, what works together. So if you are interested in further information on OTP.net, the best place to go is our OTN website, otn.oracle.com/.net. To get information, the latest news and latest white papers or Oracle by examples or videos, we post that that news on Twitter, so you can sign up to subscribe to our Twitter feed, as well as our videos. You can sign up there on our YouTube channel if you want. And if you have just a question, you can always email me. I'm always happy to try to answer all your OTP.net or HA questions when I can. So why don't we begin the Q&A?
Okay, Alex, this is Christian Shea. Can you hear me okay?
I can hear you just fine, Christian.
All right, so we have a few questions that I saved for the end here. So the first was, can we use fan for non-rack environments or single instance?
Yes, you can. As long as you have, so let me go back a couple slides. You can have things like data guard, single instance, there's rack one node you can use, but anything that, the real software, I guess, is the clusterware or some kind of clustering software that has the fan enablement. So CRS, as I mentioned, was the thing that was kind of providing the messages to OTP.net connection pool. As long as that's running and able to deliver the messages, the fan messages to OTP.net, that's fine, because CRS will look at, hey, this database went down, the single instance went down. I'm going to deliver a message to the OTP.net connection pool, alerting them that it went down. Obviously, the entity that goes down can't tell you that it went down because it's failed. But the CRS that's there can tell when the database has gone down because it's watching the database. So as long as you have that CRS with fan running, watching that single instance database, you can use it.
Okay, great. Another question that we got is you were talking about active data guard. Can you use these features for non-active data guard?
So this matrix is perfect for that. So yes and no. So here you see no with runtime load balancing, but yes for everything else.
Okay. And the last question that, well, actually, there's one more, but another question that we got was, did you say that some of the features, some people said that they have both managed and unmanaged OTP.net apps throughout their company, and they wanted to know, to make sure they understood that some of the features don't work over TAF when you're using managed, and so they should use fan instead of TAF.
Yeah, so fan will work with managed and unmanaged OTP.net. TAF only works with unmanaged OTP.net because it is an Oracle call interface feature. I might have forgotten to mention it, but application continuity is only unmanaged OTP.net for now. But transaction guard works with both managed and unmanaged. Runtime load balancing works with both managed and unmanaged. So does fast connection failover, managed and unmanaged.
Okay, and TAF works with OTP.net managed.
No, unmanaged. TAF works only with unmanaged because
only with unmanaged. Okay. All right. That's all the questions that we have up till now.
Okay.
So if anyone has any additional ones, try typing them into the chat screen. Otherwise, that's it.
Yeah, it's 1 hour exactly, so we have very good timing.
Yep, I don't have any other questions in the questions box, so if you gentlemen are finished, I will say thank you to all the attendees, and I hope everyone has a great day.